screensaver, my computer screen shows two circles that start like dots and expand outward. At the instant that the first circle has a radius of 9 centimeters, the radius is increasing at a rate of 3½ centimeters per second. Find the rate at which the area of the circle is changing at that instant. Indicate units of length.
Okay, so we know we have to use the area formula. So let's write out Fuigi. And if you forgot, it's okay. This will be a good reminder. So F stands for find. We're finding the rate of the area. So I'm going to write dA over dt. And then it says when. It was when the radius is how many centimeters? 9. And they gave us a given rate. The given rate is increasing, so it's positive, and that is referring to the radius. We have dr over dt is equal to 3½ centimeters per second. And because we're looking for the rate of the area, I need the area is equal to pi r squared. Okay, questions on how I got all these? Good? So then let's go ahead and derive this. When I derive 1a, it is 1, but we also need to derive implicitly dA over dt is equal to, and then deriving this will be 2 pi r. 2 pi r, and then we also need to add in what? dr over dt. And let's see what information is already given. dr over dt is given, and the radius is given. So that's going to give us 2 pi, the radius of 9, and then the rate of the radius was 3 over 2. I would actually knock out the 2 and the 2 on the bottom. So that's going to give us how many? 27 pi. And we have to write it in sentence and always steal the sentence stem from the question. I would start with the rate at which the area, blah, blah, blah. And the units do matter. So let's write the rate at which the area of the circle is changing. And that is our rate at 27 pi. And because it's the area, am I just going to say centimeters or centimeters squared? Centimeters squared per second. I think I'm going to make it a little more detail. When the radius is equal to 9. So again, writing more than enough is always good. If it's not there, they're not going to give you any credit. Are you done on your phone? I see it. Okay, let's see where the points are going to come from. Knowing how to derive implicitly, that's the 1 point. The final with the sentence is another point, but within that, there's a hidden point. Having the correct unit is also another point. So I feel like the unit is almost like a freebie, so why not take it? What's that? Area. If it were to be volume, it would be centimeter cubed per second.
What's the one where it's like per second?
That we're going to cover when we get to multiple choice 76 to 80. Okay? It'll be reiterated. Okay, let's go on to the next one. Lauren, go ahead and read part B. I can't hear her. Try it again.
The radius of the first circle is multiplied WT equals 12 minus 12e to the power of negative 0.5t for 0 is less than or equal to t less than or equal to 6, where WT is measured in centimeters and t is measured in seconds. At what time t is the radius of the circle increasing at 3 centimeters per second?
Okay, let's go ahead and write out Fuigi. And the equation, they already gave it to us. So we're finding the time. So we're finding what is the time t is equal to. And then, did they give us anything with the when? No, they did give us the rate though, right? They gave us the, it is increasing, so we have positive. dr over dt is equal to 3 centimeter per second. And the equation given, since I wrote dr over dt, even though they said the rate is with w, I think I'm going to alter that and say r is equal to the equation. I should move it up. There you go. So write that equation out. It's kind of lengthy, but that's okay. So this will be a good one for us to kind of reiterate how to do deriving with E. So let's kind of recall. When we derive 1R, it is just 1 dr over dt is equal to. So when I'm deriving the next piece, do I even care about this 12? Nope. Now, everything revolves around this one. So as a reminder, when you're deriving E, it is itself times the derivative of the power. So by itself means the coefficient goes along with it. Minus 12. So here's my itself times the derivative of the power, which is negative 0.5. So let's actually simplify this. They gave us dr over dt, right? So I can plug in 3 into that one. And then when I simplify this piece, I have negative 12 times negative 0.5. That's going to give us half of it, which is what? 6. E to the negative 0.5t. And I know you're thinking, how is this non-calc, right? It looks like we might need one. What I want to do is, I'm going to go ahead and put the coefficients together by saying e to the negative 0.5t is equal to 1/2. That's a number, by the way, 0.5t. So my goal is to solve for t. You can either drop and cross. I think I want to do something easier. Let's multiply by natural log on both sides. Because if you remember the properties of the natural log of e is what? 1. And then by the natural log, if I were to apply the rule, we bring the power to the front, right? So really in the end, this drops. So I get negative 1/2 t is equal to natural log of 1/2. So my t is almost by itself, so I need to multiply by what on both sides? Negative 2. So that gives me, I'm going to see if I have room over here. T is equal to negative 2 natural log of 1/2. So then, that is our answer. Let's go ahead and steal our sentence stem. I will go from the radius of the blah, 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 and all that good stuff. So let's write the radius of the circle increasing at a rate of, the initial rate that they gave us was 3 centimeters per second at t is equal to, so my time is negative 2 natural log of 1/2. Okay, after I go over the point system, I want to talk about something with the negative. Isn't it kind of weird, the fact that there's a negative in front? Yeah? And our time is in seconds, right? Ooh, I almost missed a unit. What if that was a freebie? Silly me. So your first point comes from deriving implicitly, just like on part A. Second one comes from plugging things in. And then we have 1 point right here. Okay, I want to talk about something real quick. If I plug in natural log of 1/2, and I'm just proving a point here. If I plug in natural log of 1/2, ooh, not 12. It's going to give me a negative number. So that negative times the negative 2 is positive. So it does make sense that the time is positive, okay? That's just extra story behind it, okay? All right, let's go on to our last piece. I feel like the last one was the easiest. Kind of turns out that way. Okay, what's nice about part 6 on this one is that they're all independent. A does not rely on B nor C, okay? Mia, go ahead and read part C.
A model for the radius of the second circle is given by the function f, where 0 is less than or equal to t is less than or equal to 6, where f of t is measured in centimeters and t is measured in seconds. The rate of change of the radius of the second circle is given by f prime of t equals t squared minus 4t plus 4. Based on this model, by how many centimeters does the radius of the second circle increase from time t equals 0 to t equals 3?
So we're going from rate of change of the radius to the actual radius value. That means what's given to us is f prime. And if you're like, well, how do we know? Well, it's also on there. And we're trying to get to our f. So we need to go ahead and integrate. And we are integrating from time t equals 0 to 3. So let's make our integration sign, 0 to 3. And let's write out the f prime. So we have t squared minus 4t plus 4, and it's dt. And it is formal for you to put everything in parentheses, which I tend to kind of forget from time to time. So let's go ahead and add one more and divide it by that number. What is 1 more of 2? 3. So we have t cubed over 3. You can write 1/3 in front, doesn't matter. Understood 1, what is 1 more of that? 2. So we have 4t squared over 2. And then derivative or antiderivative of 4 is simply what? 4t. And we are going to integrate from 3 to 0. Let's see if we can simplify something so we don't make silly mistakes. Which of the components can we simplify further? 4 over 2? So I'm going to write out t cubed over 3 minus 2t squared plus 4t. And then we're going to plug it in. Now, do we really care about plugging in the 0? If there was a constant, it does matter. But if they all have variables, it's going to be 0, 0, 0, right? So let's plug in 3. So I have 3 cubed over 3 minus 2 times 3 squared plus 4 times 3. Ooh, that's a passionate 3. And I'm just going to write 0 just in case they feel like I'm being mean, the AP graders. So let's do this piece. What is 27 divided by 3? 9. And then for this one, 9 times 2 is 18. And then we have 4 times 3 is how many? 12. And that's going to compute to a single whole number of what? 3. Very good. So let's see which sentence stem I'm going to steal from. I'm going to mention something with the radius and something with the time, and then is blah. So let's write out the radius. Is the radius increasing or decreasing? Increasing or radius is increased by 3 centimeters from, and always mention the time, from t equals 0 to t equals 3. And again, we need our units, seconds. So how many more points do I have remaining to get to 9 total points? We had 3 on part A, 3 on part B, right? We got 3 more. So knowing to write the equation with the integration, with the bounds, everything, 1 point. And knowing how to integrate is another point. And then our final sentence is another point. Here's my advice to you. Could I choose to stop right here if I wanted? As long as you plug them in, you could stop. So I would just stop right at that point.